Alright guys, here's an Atwood machine problem. It says a mass of 75 kilograms hangs off the edge of a table and is attached to another mass of 33 kilograms by a light string. The 75 kilogram mass is allowed to fall and the 33 kilogram mass is pulled horizontally along the frictionless table. Find the following: acceleration of the system and tension. So let's draw our picture. Here's the pulley. Here's the mass on the table. This is our 33 kilogram mass. And then we have attached to that 75 kilograms. From there, let's put our forces. So we have Fg1. We have tension here, Fg2, and normal force. There is no friction. When the system is placed in motion, the 75 kilogram mass falls down, so that direction is positive. Therefore, gravity is positive, tension is negative for 75 kilogram mass, and the 33 kilogram mass moves in this direction, so this way is positive. Therefore, tension is positive. In order to find acceleration, guys, you can either memorize the equation or you can easily derive it. I'll derive it here for you. If we write out F net for the system contains both masses, so I'll just label them as M1 plus M2 times A. M2 is going to be the 33 kilogram mass, and M1 is going to be the 75 kilogram mass, as I've denoted here. Net force for the system is sum all of the forces based on the sign convention we've established. So if we start with the hanging mass, we have M1G minus tension plus tension equals M1 plus M2 times A. Tension drops out, so acceleration is M1G over M1 plus M2. We can generalize this just a little bit, and we'll do so by making it specific to this type of problem. So acceleration is the hanging mass times gravity over the total mass. So plugging our numbers in here, hanging mass is 75 times gravity of 9.8 over total mass 75 plus 33. That will give us 6.8 meters per second squared for acceleration. For part B, we need to find tension. Let's get some space here. There are two ways to find tension. And by two ways, I mean, in order to find tension, we cannot look at acceleration of the system. We have to look at acceleration of one mass only. So we're going to split our free body diagram up into two parts. So we can either choose mass 1 or mass 2. I will do mass 1 first, and then I'll do mass 2, just so we understand we'll get the same answer here. So if we look at mass 1, we have gravity, and the mass of mass 1 is 75 kilograms. Therefore, its weight is going to be 75 kilograms times 9.8, which gives us 735 newtons. Tension acts upward. This mass is moving in this direction, so that way is positive. Gravity is positive, tension is negative, right? So in order to find tension, we're going to just write out F equals ma for this mass only. So we have F net equals M1A. So that is M1G minus tension equals M1A. So tension is going to be M1G minus M1A. That will be our 735 minus 75 times 6.8. And that value that we get there is 224.6 newtons. Right. Another way to work the same problem, a little bit more straightforward. If we look at mass 1 only, mass 2, this is mass 2, and this one was mass 1. The forces we have here are tension, gravity, and normal. This mass is moving in this direction, so that's positive. Tension is positive, and normal and gravity will cancel. So the only force acting to move M2 is tension. So I have tension equals M2A. So that is 33 times 6.8, which is 224.6 newtons. So that gives you two options. Both will get you the right answer. You just have to be careful about signs and which mass you choose. Hope that's helpful, guys. Thanks.